Now, a Gaussian process or a normal process is something that occurs very commonly in nature and in engineering. Okay, it's called a Gaussian or a normal process, and the process is given by this distribution. Okay, this looks quite complicated, but you probably much more you'll recognise that distribution. That's the equation. Sorry, that's the plot of this equation. Okay, and it becomes a lot simpler if your mean is one. If your mean is 0 and your standard deviation is 1, then obviously this becomes a lot simpler. This suddenly becomes x divided by 1. So this just becomes 1/2 x squared. And obviously down here, 2 pi times by 1 squared is obviously 1. So you just end up getting a much simpler equation. But that's accommodating all means and all standard deviations. And so like I said, you get a plot that looks like this. Then depending on your standard deviation, it either becomes wide and low or short and tall. Okay, because the area underneath this curve is 1. Okay, so all my, if my process has a normal distribution, then it's got this bell-shaped curve, which is the other term you may have seen, and every possibility, every possible value or variation will be under this curve somewhere. Okay. Like I said, this occurs in engineering, occurs in nature. If I took a large enough number of people and I measured their heights, okay, the distribution of that would be a bell-shaped curve. Okay, if everybody of the same adult age and stuff, you get a bell-shaped distribution. Okay, so most people will be around the mean, but obviously as you get very, very tall people over this side and very, very short people over here, but you get this bell-shaped curve. And like I said, engineering processes will often have this shape as well. Okay, so it's worth bearing that in mind. In terms of the standard deviation, there's some interesting characteristics. Okay, the probability that my x value is going to be between, c will be a certain value, 1 standard deviation. Okay, so I could work out the probability with that distribution that my c is between minus 1 and 1. So between 1 standard deviation of the mean, I can take the integral of my p of x term. Okay, knowing standard deviation and my mean value. Oh, sorry, this is assuming mean is 0, so I don't need to worry about that. Okay, I can take the integral and I get certain values. Now, like I said, if I'm looking between 1 standard deviation and the other, I know that 68% of the time I'm going to be hitting that variation. If I up that to say I'm looking between 2 standard deviations, I know that 95% of the time I'm getting that. 3 standard deviations, we're getting close to 1, and 4 standard deviations, I've got almost every single sample in there. There's only really the extremes and the lower extremes.